Hello and welcome to another video from Ellensburg Amplifier Repair and Service. My name's Todd. And what we have here today is a Planet Audio... Oh, hold on, let me see what this thing is. It's a Anarchy... It's the Planet Audio Anarchy... the AC5000.1D amplifier. That is in for repair. So I wanted to go ahead and point out some things for this amplifier here. So when you first open up the cover and you see stuff like this around the capacitors, your first thought is going to be, is this cap, has it vented? Has it overheated? Has it vented? Has it let go of all of its good electrolyte? So I do believe these have failed. These are the output, well, these are the rail capacitors for the amplifier. So you could already suspect a problem at the output if these have vented. So what I do is I'll pull the cap off, and you can see right in the middle here that it looks like this capacitor has vented. Maybe, and if it hasn't, it is definitely bulged up a little bit. I can't see if that seam has been popped or not, but I'm just gonna pull a couple more off here. And yeah, you can see on the top of these capacitors here, it possibly has vented, and these capacitors are definitely sticky. So probably some electrolyte here. So they are sticky. And they are swollen. And so what I'll do is I'll just run my finger over the top of the capacitors and feel, like this one here is bulged up too. So what I'll do is I'll feel that cap and see what has come loose on this. I'm going to pull this cap off too and see what we got underneath. Yeah, so it's bulged up too. And you can kind of get an idea of what happened here. So this bank, as you can see, this trace right at the bottom, these three capacitors are in parallel. And these three capacitors are in parallel. So the parallel set here has either gone into a lot of ripple that has caused the capacitors to overheat. Are these are 105 degree capacitors, I do believe. Let me just double check that real quick. Yep, 105. So these are 105 degree capacitors, Celsius. So ripple, as you start to increase the ripple current through the capacitor heats up. And as the capacitor heats up, the electrolyte boils and it finds its way out. And then the capacitors fail. So this really is pointing me back to the output. So I'm going to turn my meter on here to good old resistance mode here. Because this will show me the resistance values between the pull down resistors, the gate values. Just a quick, easy way for me to test the transistors in this thing. And this card right here, I despise these cards about as much as the old Orion, those 2500D cards. I despise these about as much. They're prone to failure. They just have an absolute ridiculously high rate of failure. As you can see, because they put two fans in front of it, these get just smoking hot. And what happens is these cards fail, takes out output transistors start to fail, you get high ripple in your output, and then things just fall over like dominoes. So I'm just going to do a quick test on the output transistors here. 10 ohms, gate source, 100 ohms, gate source. 100 ohms, 100 ohms, 9K, 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 and 9K. So this low side bank, I'm assuming it's a low side, does have a short in it. This transistor, like I said, has 10 ohm short, and you can see this gate resistor here has been a little toasty. 46 ohms. So you can safely assume this transistor here has failed. So drain and source, yeah, 1 ohm, 1 ohm, 1 ohm, and 1 ohm. Of course, you're gonna have 1 ohm across the board because they are in parallel. So I'm gonna safely assume this transistor right here is going to be the culprit. Easiest way to determine that is just to cut the legs at the transistor and check your resistance again. Oh, there it is, 9K. So 9K, so that means you have 10K pull down resistors. Are we correct on that? Yes, we do. We have 10K pull down resistors. So this one transistor failed. So if you take the bank that failed and work your way back, you'll see it's the low side bank because it goes through your shunt resistors. Most all your overcurrent protection circuits will always watch the current going through your low side. So if you check your continuity between your low side shunt resistors and the side of the capacitor that failed, you'll see it goes straight through. So this here is your low side bank of output capacitors, of rail capacitors, excuse me on that. So this is supplying your negative rail because your output filterings are right here. So it's a negative rail fault. More than likely the drive card is damaged. It may have survived. It's kind of rare for these to survive, but I don't see any heat damage on the card. So what we'll do is we'll get this board out. I will see what transistors are used. So they use the probably 31N20Ds that you see here. So yeah, on the negative side here, they are using the 31N20Ds, which I have several videos out going over the 31N20Ds. You got to watch out. There's different 31N20Ds that'll work with different drives due to the manufacturing differences between the batches of these 31N20Ds. So what I'll do is I'll get this all tore apart, get the board out, and see if I can even find some of these 80-volt rail caps that'll fit in here. So I will be right back with you guys. All right, welcome back to this Planet Audio board here. So I got the board obviously out of the heatsink, and I'm just going to continue moving forward on the repair of this. Again, we do have the 3 failed negative rail capacitors, so we're going to remove these and install new negative rail capacitors. So let's heat up the Hacko and let's get these rail capacitors pulled. And while that hack was heating up, I just want to double check and make sure I don't have any shorts on the output. 9K, 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 and 8.9K. So we're looking good on the output. And the power supply, as I had showed earlier, that we do have rail capacitors that are charging across the rectifier, so I don't suspect the power supply to have any failures on it. And it's pretty typical for this type of board too. They're using the SG3525 to drive the power supply. It looks like they're using parallel transistors, which is good to see too. It's kind of leading me to believe that these IRFB, the 3607s, might carry a little bit more current than the 3205s. I'll have to double check that. So let's flip this over and get these rail capacitors pulled out. And as you can see, I have circled where the rail capacitor locations are, so I know where I'm going without having to flip the board over a million times. We're just going to go ahead and remove this lead-free solder. Removing rail capacitors is tricky. They use a lot of software, and the vias on these things are usually pretty hard to clear. So it might take a couple tries to clear the solder out of the via due to the lead-free solder that they used. So I'll just add a little bit of leaded solder. And there we go, then it clears that via up really nice. And that lead-free solder wreaks havoc on these desoldering guns, so you want to make sure you keep your gun pretty clean while you're doing that. And you can see right down into the via where you still have some solder hanging around. You can look right down in there. Well, at least I can. You guys can't see it in the camera, but I can see where I still have solder in the via. Just make sure the pin's nice and toasty warm there. Clear it out the best I can. Because if you don't get it cleared out and you go to pull on that rail capacitor, you'll pull that via right out of the board. So I'm just going to reach up in here and just lightly wiggle the capacitor. Just to see how free it is in the via. You can hear me popping the glue on it. It looks like this one here is still giving me a little bit of a bad time, so I'm just going to keep heating it up. There we go, that looks pretty clear. So what we'll do is we'll flip it over and see if we can pull these out of here without doing any damage to the board. And they do glue these in pretty nice. And sometimes what I do is I'll use a heat gun to heat up this glue that they use, and it softens it up, and you can use your tweezers to peel that glue up. So there's one. What I'm doing is I'm just using the point of my tweezer just to poke small little holes in the glue there. That'll help it separate off that capacitor, because they got pretty good amount of glue down in there, and it pops right out. And you'll know when you are getting your vias cleared out good, because when you pull the pins on these, sorry, my autofocus is turned off to keep the board in view, but the pins, you won't have any copper around this. If you pull this out and you see copper, like a copper tube on this, it means you pulled the via out. And once you pull that via out on a rail, it's an interesting task to repair that. So maybe one day in the future I'll have a video out on how I repair the main current carrying vias on these. So that's the rail capacitors removed. And then what I'm going to do is I'm just going to place my new capacitors in the locations. And we'll solder them back in place. All right, and the board here, you can see before I removed it, I put a little negative sign on the board here, but also the board itself, the silk screen is identified for the negative side of the capacitors here. So it gives you a good indicator of which way they go back in. Of course, the trick is getting these legs to line back up again. Rail repair sometimes is not the easiest thing to do. Oh, I got a little bit of this lead-free solder just hanging out the top here. Get rid of that real quick. There we go. And we got some new rail capacitors installed there. So I'm going to go ahead and flip it over and solder them in place. And again, yes, I like to use my desoldering guns as my soldering tool. No need to have a huge soldering iron for these big traces when you already have a huge soldering iron to remove solder. And I like to make sure all the solder is flowed nice throughout the whole trace. Just like that. And since we have it flipped over, what we're going to do is we're going to go ahead and install my 12 volt 2 amp supply here. Let's see. And again, a good rule of thumb when you're doing this kind of work and you've already pulled the end off and you don't know what's positive and what's negative, you can always look back to your capacitor that filters your 12 volts coming in from your battery. So if you flip it over, let me get you in the power supply side here. So these capacitors, whoops, wrong side, sorry guys. These capacitors here filter your 12 volts coming in, and they're marked negative positive. So your negative side of your capacitor will always be connected to your negative battery terminal. So the negative side of that capacitor is here, so that means this terminal here is the negative battery terminal. For the sometimes people don't have these small current limited supplies, and if you hook this up backwards with a high current supply, you will take out the reverse polarity diode or do further damage forward in the remote circuit and the driver part. So a lot of stuff can happen if you use high current during your testing. So there's the board, the new negative rail capacitors. I'm just going to quickly locate the rectifiers. So the rectifiers are right over here. You'll see them labeled as D for diodes, because that's what rectifiers are, they're diodes. So you're going to have your common cathode and your common anode rectifiers. Let's see what one they're using here. These guys are using the, oh, I can't even read them. They're using, so these guys are using the 2020 CTs and CTRs. So they're the 20 amp 200 volt rectifiers. Which makes sense that you see 80 volt rail capacitors. So if you take your 80 volt rail capacitors times 2, because you're going to be positive and negative on the sine wave, you have 160 volt potential. So you want to use rectifiers that are rated above what your rail can produce. So I got my scope started. Let's see, let's go ahead and get the scope started on the screen for you guys. That's what I like about the Rigol oscilloscopes is it's got a really just a straightforward software for getting this scope up on the screen for you guys. So let me get fired up here. All right, so there's the oscilloscope. Now, since we don't have a short in the output section, in the transistors, you have kind of a 50-50 chance that there's no short in the card. So again, I'll go back to my just simple testing methods of how I look at rail voltage as an indicator of what's going on with the amplifier. So I'm going to make sure all my knobs are turned fully counterclockwise. You'll be amazed at, like this one here, my gain was up about 3/4. You'll be amazed, sometimes you'll get these gains that are cranked 100%. And when you go and fire up an amplifier outside the heatsink and you're cranked up to 100%, sometimes bad things can happen. And I'm going to leave the sensitivity, input sensitive alone because I don't have an input signal yet. So I'm just going to locate my LEDs. I got a power LED and I have a protect LED. So you can see the rails are just slowly discharging. So none are dropping. Again, if you have a short in the output, that rail will disappear really quick. And so the reason why the rails are discharging is that means it has discharge resistors going across the rails, which is probably going to be, where are we going to find that? Pretty sure that you're going to find the rails. Yeah. So right over here, you have two resistors. One's going to be discharging the positive rail, one's going to be discharging the negative rail. Yes. And so these are responsible for discharging these capacitors. And this is where I go back and say, again, guys, keep your hands clear of the rail voltages. Keep your fingers out where they don't belong. Some amplifiers don't have discharge resistors, and these capacitors will stay charged for a very long time. Some of the Type 4, the car audio bargain boards, those will hold a charge. I've had them for a month sitting aside, and it still had a charge on it. So I write live on the box if I don't discharge the rail capacitors. But it's just common practice for me to discharge rail capacitors if I'm working on them. But these have pretty quick resistors to discharge those rails. So I did get a green light, a good green power light, which told me that I must have a signal on the output. Maybe 50-50 chance. So there's my power LED. And I do. So we do have switching signal on the output transistors. I just want to make sure that they're not getting hot. And again, I am keeping my fingers away from these tabs because they do have rail voltage on them. So if you're in there feeling for temperature, always be mindful of where your voltage is. So I do have switching. So the drive card itself is still good. Still okay. Probably did not heat up to a point where anything got damaged. Sometimes I'll rebuild those cards just for durability of the amplifier. I'm just going around checking the signals here. So it's got great switching. And so as long as they're not heating up too, I can always go ahead and put in a signal. So let's go ahead and fire up my signal generator and get my RCAs here. Now, something I don't talk a lot about is my signal generators. I use a Heathkit, the IG1272, as one of my primary signal generators. I do have a Fieldtech signal generator, a digital one, electronic one, but you got to be mindful that they have an output that's referenced in two different ways. Some amplifiers will not, I shouldn't say will not, does not like the Fieldtech signal that I try to give it. What do I have here? So input sensitivity, I have 100 millivolts to 2 volts. So I'm gonna go 2 to, what is this? 2 to 5? 2 to 8. This will go up to 8 volts on the input. So I'm at 1.5 volts. So I just want to make sure my input signal is really low. And we'll go ahead and fire this up and see if I have a good output signal here. Maybe it will like it, maybe it won't. Hopefully it doesn't blow up in my face. There we go, we got a green light. Change the time base and the voltage, and there's our sine wave. So really this was just a output, I'm sorry, not an output, this was just a rail capacitor failure. So all I got to do is replace a bank of 31N20Ds and this amplifier will be good to go. So again guys, I do thank you for watching. Keep your fingers safe, keep it out from where they don't belong, and we'll catch you on the next one. Leave your comments down below. Catch you on the next one.